Welcome back to my channel, everyone. Sweet Tips here. What I have here is one of my gold refining temporary waste containers. I add my gold refining waste to this container. I've got another one back here. They're both getting full. And so what we need to do is transfer some of this waste solution into my stock pot. My stock pot has pieces of copper in it like this, and then we pour the waste solutions into the stock pot, and the copper in there will cement out any traces of precious metals that will remain possibly in our liquid here. Those precious metals will cement out and fall to the bottom of my stock pot. This one's been settling for about 5 days. Now what we'll have in here is just copper in solution. We're going to siphon this solution out down into my waste treatment bucket. And my waste treatment bucket is full of iron, pieces of iron like this. And in here, the copper gets cemented out onto these pieces of iron, so that what I end up with is just iron in solution, and all the copper gets removed by the iron in this waste treatment bucket. So the gold refining waste that could have precious metals, including platinum and other platinum group metals, in solution with the solution, gets added to the stock pot. In the stock pot, it's full of copper. Those precious metals, which are highly toxic in solution, will cement out onto the copper, and the copper will go into solution. So now we have an acidic copper solution in this stock pot. And now we're going to siphon it out, the copper solution that's in there, down into our waste treatment bucket that's full of angle iron down here. The copper will come out of solution onto the pieces of iron in here. The iron goes into solution, and we end up with a solution that's full of iron, and all the copper is removed from it. We're going to siphon our solution now out of our stock pot and down into our waste treatment bucket now. Here you can see the pieces of copper in here, and that black mud on the copper will be precious metals that have cemented out onto those pieces of copper. Now that we've got some room in here, what we're going to do is we're going to transfer the gold refining waste in our flask right here. I'm going to pour that right into our stock pot, and we're not worried about if gold, let me see here, let me get the angle right, if this gold in here gets poured off into here, because that's all right. Some gold in solution may exist in this liquid that we're pouring off. It shouldn't, but it could. So we're just going to add this liquid now to the stock pot. And now, this is the gold that we have left in there. We're going to go ahead and get this out of here today. Let's move this thing out of the way now, and I'll bring down this waste container. This one is colored a different color because it's got ferrous sulfate in it, but This will contain some precious metals, so we're going to top off the stock pot with some of this liquid. I do this reaction outside because it contains some fumes, so let's take this out, put it under our rain covers. This is my stock pot number 2. It's been in here bubbling for about 5 days. We'll get this one out of the way, and what we'll do is put the one we just filled in its place. Put the lid on. Put the bubbler tube just bubbles air through it to keep some movement going, so that the precious metals can cement out on the pieces of copper in there. Now I just cover this up. It's not emitting any more fumes now since it's been out here reacting for about 5 days. Just cover it up and put it in my shop and let it settle. This beaker has some electrolyte in it that we cemented the silver out of it. There's a piece of copper pipe in there. And when this is complete, what I'll do is I add this blue copper nitrate solution to a bucket that's full of pieces of copper. And what this will do is this will cement out any remaining silver that might still be in solution here, along with any other precious metals that might still be in solution. So this is kind of like my silver refining stock pot. Then once this has been settled and set for a few days, I siphon the solution out of here down into my waste treatment bucket, and we'll cement the copper out of that blue copper nitrate solution here in my waste treatment bucket. Now let's go ahead and siphon some of the solution out of our silver stock pot down into our waste treatment bucket. Now we'll just get this out of the way, and then we'll take our waste treatment bucket full of copper nitrate now in with that iron. We'll take this out and set it up underneath the rain cover. Here's our copper nitrate in with the angle iron, and once that reacts, all the copper will come out of that solution, and then I'll just have iron in solution. Then we can treat the acidic iron solution with sodium hydroxide and get it ready for disposal, non-toxic. We've got our waste treatment caught up a little bit. Now what we'll do is see about getting the gold out of this temporary waste container. If you've watched some of my previous videos, you'll notice that when I do the rinses of the final refined gold, I pour those rinses in this bottle, and a little bit of gold gets poured over during those rinses, and it accumulates in here. It's all gold down in here, gold powder. So we're going to go in here and try to get this gold powder out, and maybe melt up a nice little ingot. But first, before I do that, I've got some silver over here that I'm dissolving in nitric acid to make electrolyte, to augment the electrolyte in my silver cell. So we can't process the gold and the silver at the same time in the fume hood because we risk cross contamination. Here's a look at my silver cell. I've got a time-lapse camera set up on this. Today is Wednesday. I started this on Monday, I believe it was. And so what we're trying to do is get down in there and get us a time-lapse of the silver crystal growth in the silver cell. Unfortunately, with all that equipment in front of my silver cell, I can't get down in there and look at it. So anyway, we should have a nice several days worth of time lapse of crystal growth if I got this camera set right. So we've got the silver out of the way now, So what we'll do is go ahead and dissolve the gold that's down here in this flask. That's pure gold down there, gold powder. We'll begin by taking this solution here. This is going to be some gold that was stuck to a beaker, and I put a little aqua regia in here and dissolved it and got it all off the glass that was inside of there. There's gold clinging to the glass, so I put some aqua regia in there and got that off. So this will start dissolving the gold that's already down here in our flask as soon as I pour this in. We've got some hydrochloric acid down in there, along with some aqua regia from that beaker that we just added. Now, just like any other refining, I'm going to add some sulfuric acid to precipitate out any lead that may be present. Not much. I'm going to pour in some hydrochloric acid, just about maybe 100 milliliters or so, not much. I'm rinsing the inside of the flask with some hydrochloric acid. Now we're going to put in a few squirts of nitric acid. This will form aqua regia in here, and it should dissolve the gold pretty quickly for us. Let's see, let's go with 6. Let's go with 6.5. That's about 3 more, so 9 total. 9 3 milliliter doses of nitric acid in our container here, and we should see it react even cold and start dissolving the gold immediately. Just about got it all to go into solution. This is took about 5 minutes or so, and as soon as we get the rest of this to dissolve, then we'll be ready to go to the next step. We've got everything to dissolve. I'm going to reach in here and grab this. I got a glove on. I'm going to pull it down off the heat. I let it boil because that will help rid that solution of any excess nitric that may be present. I've allowed this solution to cool to nearly room temperature. I've got some ice in a beaker. This ice is made from distilled water. Now what we'll do is transfer the solution out of our flask into this beaker with the ice to cool it down. Now we're going to get set up to filter the solution. Let's go ahead and filter our gold now. It should already be relatively high purity. Our solution came out crystal clear, bright. We did have a little bit of junk up here in the filter. We've got everything pulled through the filter now. Take off our funnel. You can see there was some stuff in there. So it's a good thing that we filtered. Now we're going to add the gold solution to a clean beaker here. I think since we may have some platinum group metals in here, what we're going to do is use ferrous sulfate to do this precipitation. Should only be about 50 grams or so. No, not 50, half an ounce, about 15 grams of pure gold in our solution. You can tell by that stain we've got gold in solution. This is about 1 pound of ferrous sulfate dissolved in 1 liter of solution. That's the concentration. So what we're going to do is start adding some ferrous sulfate in small amounts. Stir this up now. Let it set for a second, see what it's going to do. I'm trying to figure out how much ferrous sulfate it takes to precipitate a given amount of gold. I'm going to add a little bit more of the ferrous sulfate now, just a few hundred, maybe 100 ml or so. And stir it up. There's definitely gold precipitating. I can see it floating on top. I'm going to add a little bit more of the ferrous sulfate, maybe about 100 milliliters. Yeah, we're definitely get some precipitate in here. Let's do a quick stannous test and see how much more gold that we have in solution. All right, see that brown stain? It's not a whole lot, but we still got some gold in solution. The nice thing about the ferrous sulfate is that it will only precipitate the gold, no other metals, and we probably had some platinum group metals in here with this gold in my waste container. I'm going to add about another 100 milliliters here. Give it a stir. We'll reach in here and get another stannous test. See where we're at. Boom. No reaction on the filter paper there. I'm thinking we're complete. We've got all the gold precipitated out of here now. Well, that took about a little over half of the ferrous sulfate that we had in here. And that was, what was that? That was 1 pound in 1 liter of solution. So this will give us a rough idea of what we need as far as concentration and amount of ferrous sulfate to get our gold to precipitate. It's only been about 5 minutes since we completed the precipitation with ferrous sulfate, and this gold is settling out quickly down on the bottom of our beaker. That ferrous sulfate solution, the gold settled very quickly in there, which was kind of unexpected. I don't have much experience with ferrous sulfate, but as you can see, there's the gold down on the bottom. Now we'll pour off this waste solution. Ferrous sulfate in solution looks just like gold in solution. I want to re-verify, make sure we've got all the gold precipitated out of here. There it is, negative stannous test. There's no gold in this solution that we poured off. Let me rinse with some hydrochloric acid. This gold will be very pure because the ferrous sulfate only precipitates the gold, which makes for some high purity gold right off the bat. I'm rinsing it with some hydrochloric acid. Alright, I think what we'll do now is add a little hydrochloric acid to our gold. See it there? And I'm going to set it up on the heat. We're going to give this a quick boil in hydrochloric acid. It's been boiling in hydrochloric acid now for about 10 minutes. What we'll do is take this down off the heat now. I'm going to rinse the inside down a little bit here. Kind of did spatter some of the gold on the sides of the beaker here. Oh yeah, that gold looks good now. Nice color to it. Let's pour off this hydrochloric acid boil. Let's do this first. Let's get a stannous, make sure that we don't have gold in solution. The reason we're getting this is because I don't have much experience with the ferrous sulfate. And you can see by that test, we've got no gold in solution. Now we can pour off the solution that we're certain that there's no gold in there. Just add it right to the waste container. I'm going to rinse it with some hydrochloric acid. Here's what our gold looks like down in our beaker. I love the color of it. I added some more hydrochloric acid after that hydrochloric acid boil, and if you notice, our solution is nearly colorless there. Maybe it's got a little bit of amber tint to it. But that hydrochloric acid boil that we just did seemed to have helped greatly. So what I'm going to do is stick it up here. We're going to put some more heat on this, low heat. Just let this simmer in hydrochloric acid for a few minutes before we proceed. The gold has been on simmering in hydrochloric acid now for about an hour. I just left it on there on low. And what we're going to do now is I've got some ammonium thiocyanate. This is a sensitive test for iron. I'm going to grab some of these crystals and put it in this spot plate right here. I'm going to reach down in here and just get a little bit of our solution in this pipette, just a drop or so. And now we'll come down here to our spot plate, and I'm going to put this in this ammonium thiocyanate. If it turns blood red, that means we've got iron in solution. Oh, not bad. It's just turning pink there. So that's not bad. We still got a little bit of iron, but it's not real red, as if we had a high concentration of iron. Now let's get this solution off the gold. Just going to pour it off into our temporary waste container. I'm going to rinse the gold with some cold hydrochloric acid. Now, if that don't look like pure gold, nothing does. Now we'll give this a couple of rinses with distilled water. Settles quickly, looks really good. I'm going to give it a boil in some distilled water. Just boil it for a few minutes, and that gold looks really, really good. I'll set it up on the heat over here and just give it a quick boil in distilled water. Alrighty, we've got this gold boiling in water. I'm going to pour this off as a waste solution here. Give it a quick rinse with some fresh water. Man, this looks like this could be good with just a single refining. Man, that gold is absolutely gorgeous. I'm going to add some hydrochloric acid. Now we're going to add a little bit of sulfuric acid, just in case. Hurts nothing, costs nothing, provides a big benefit. Now let's get some nitric acid in here. This will form the aqua regia that will dissolve the gold. I'm going to use 2 3 milliliter droppers in there for a total of 6 milliliters of nitric acid. Now what we'll do is stir this up. I'm going to set it up on the heat now. I've got the solution boiling now. All the fumes have cleared up in there. I'm going to pull this down off the heat and let it cool down. And we're going to add some ice to cool our solution down. All of my ice is made from distilled water. Gonna filter our solution now. Here we go. We're going to do the precipitation. I'm going to use stump out this time and drop the gold with sodium metabisulfite. Here we go. I always forget to test with stannous, so we'll do that now. Just to verify we've got gold in solution. It's always a good idea to do this before we precipitate out the gold. Alright, our first spoon of stannous, or our first spoon of SMB has gone in. This is spoon number 2. I think that should just about do it. Let's get another stannous test, make sure we got everything to drop. And there you can see negative stannous test indicates all the gold has come down out of our solution. I've allowed the gold to settle for about an hour and a half, and if you look over here in our temporary waste container, we've got a light dusting of gold down in the bottom there. This is the makings for our new waste container gold recovery video in the future. It accumulates in there, and then we take the time to do what we're doing with this right now, which is to recover the gold out of there. It's like an offline savings account. Now we're going to take our waste solution and dump it off into our temporary waste container. Alright, here's what our gold looks like down inside the beaker. beautiful. Let's dissolve this gold one more time. I'm adding about 150 milliliters of hydrochloric acid. Now we'll cover it up, put it up here on the heat, and we're going to dissolve it a third time. Let's add a few drops of sulfuric acid. This should take care of any lead that may have made it this far. I'm adding some nitric acid. The last time it took 2 of these 3 milliliter pipettes. So I'm going to put in 1 3 milliliter pipette. And we'll start with that. We've added less nitric acid than we need. What I'm going to do now is add small doses of nitric, just a little bit at a time, so that we get just enough nitric in there to just dissolve the gold. And this way we won't have any excess nitric in our solution when we're done. I'm trying to get the rest of this gold to dissolve using the absolute minimum amount of nitric acid. I've cranked the heat up on this now. You can see the fumes have cleared up. I've got a little bit of nitric left in here. So we're going to start dropping it in a drop at a time. You're going to get a big reaction here as soon as we drop it in. I'll go ahead and put a little bit more in. Trying to get the rest of that gold to dissolve with the absolute minimum amount of nitric acid. If we do this right, there won't be any excess nitric in our solution because we've added just enough to just dissolve the grains of gold in there. This takes a little extra time, but if it's done correctly, it'll save us big headaches in the end. I've got about 1/2 milliliter. I'm going to add it in real slow. Just a few drops at a time. All right, this solution looks fantastical. Everything's gone into solution. I'm going to pull this down off the heat now and let it cool off and get it ready to filter. I'm going to add some ice to cool this down. Adding ice causes the solution to lose its ability to retain dissolved silver chloride. Here's our solution, nice and cool. I'm going to go ahead and pour it through the filter. Cooling the solution causes the pores in the filter paper to cinch up, get tighter, and that promotes filtering out very fine particulate from our gold solution. I've got everything pulled through this filter now. Rinse it out real good, and I've got everything set up back here, so we might as well do a SO2 gas precipitation. I'm going to add some SMB to our reaction flask here. Put some water down in there. Haste makes waste. I've got the sulfuric acid in this addition funnel. It's got an equalizing port on it, so that we don't pressurize and stop the flow of the liquid into the gas generator. Gas generator is already making a little bit of gas from some residual reagents we had in there. Let me get this thing out of the way. Let's put this in here. And I've got a clean beaker. I'm going to set it up on something to get it up in the air so we can watch the reaction a little better. Now we're going to add the gold solution to this clean beaker. Not very stable up there, but I think it'll be okay. We're going to start by diluting our gold solution. I'm going to fill this up to about the 1,000 milliliter level, because this reaction happens best from a dilute solution. Here we've got an equalization funnel. It's got a tube that will equalize the pressure between the gas generator and the funnel, so we don't stop the flow of gas or flow of acid. We're going to drip that sulfuric acid down onto the SMB that's in our generator flask. It's going to follow this tube, come out of the gas generator, loop down and around, and come up and bubble through the sulfuric acid. Sulfuric acid will remove any moisture and cool the gas and clean it for us. And then the output of that flask, the clean gas, will come out of this tube right here to the end of our delivery tube. So here we go. We're going to start the flow of acid now down into the SMB, the gas generator flask. Just want to get a small flow going at first. And that should work. Got some gas coming out of there. Now let's take our delivery tube. We're going to stick it down here into our gold solution and start doing the precipitation with SO2 gas. Okay, we're going to try to do this in real time. Could take a few minutes. Make sure everything's tight here. We're at about 1 minute into the reaction. Always does this to me. Gas production slows way down for some reason. Let me flow some more acid in here. Oh, there we go. I can see a definite color change in there. This is about 2 minutes into the reaction. There it goes. Flashed over to gold that quickly. It's about 2 minutes and 20 seconds into the reaction. I see some nice colors going on in that in the beaker as the SO2 gas reacts with the chloroauric acid solution and causes the pure gold to come out of solution. Should have done this before we started, but we're going to get a stannous test now and see if we still got gold in solution. You'll notice a brown color on the end of the paper there. That is particles of gold that's clinging to the paper. As you can see by that stannous test, we've got 0 gold in solution. The reaction is complete. I'm going to shut off the acid flow to the gas generator. And what we'll do now is take the delivery tube out. It usually gets coated with gold. See that? Spray that gold off. There's our gold down there in the bottom. High purity gold. And we've got some floaters up here. Let's see if we can knock some of this down by spraying some distilled water in here. I've allowed this gold to settle completely. Went in and had me a big old Thanksgiving feast. I hope everyone else is enjoying their Thanksgiving. Now what we're going to do is pour this solution off of here. It shouldn't have a whole bunch of contamination in it because we used the gas. So, oh yeah, look at that. Clear and colorless solution sitting on top of the gold. I'm going to pour this off now into my waste container. Okay, here's our gold. Triple refined, high purity gold. Should be ready to melt, just like it is right there. Let's get our pure gold into a melt dish now. Here's our pure gold, triple refined. Now we're going to do a melt and pour us a bar. Here's our pure gold bar. It looks fantastic. Look at that thing. And we were expecting about 15 grams. Looks like we got 14.6. grams. That's going to be 0.47 troy ounces. Here's our final bar. 0.47 troy ounces. 0.47 OZT means 0.47 troy ounces. Let's get it on the scale here. 14.6 grams. We've got 0.47 troy ounces. And this will conclude the Happy Thanksgiving Day gold bar refining video. We'll list this on my eBay site. And that'll conclude the video. Thank you for watching.